This video is for the lesson 3.9 homework. Today, so the transformation we're looking at today is called horizontal shifts and vertical shifts. And it's a translation. Shifting things left and right, shifting things up and down. So number one, what is the name of a change in size or position of an object? This is a transformation. So all of them, shifts, reflections, rotations, those are all considered transformations. And then two, what is the name of a set of basic functions from which related functions are derived by transformations? These are called parent functions. And the parent function for a linear function, what we've been doing is f of x equals x. Sorry, it froze. That's the parent function. And so what that is, every other line that we have graphed so far has been transformed from that. So f of x equals x. And that's what it looks like. It goes straight through the origin, and the slope is 1, up 1 over 1. Every other line has been transformed from that line, either shifting it left and right, up and down, stretching it, compressing it, reflecting it, all different kinds of things. So all we're focused on today is just moving this graph left and right, and then moving it up or down. And so you can see those movements are similar. When I move them up and down and left and right, it kind of moves it in the same way. All right. So we're going to do this first mathematically. So when we shift a unit down, all we're doing is messing with the y-intercept. So when we shift it up or down, you're just messing with the y-intercept. So if I have f of x equals negative 6x minus 3. If I want to go 6 units down, mathematically, what would you say we're doing if we're taking something down? Going negative, what's the operation though for going negative? So up or down, you're going to, if it's down, you're going to subtract that number from the y-intercept. If it was going up, so let's just take the same function here, negative 6x minus 3. Say we're going up 6. I would add 6 to the y-intercept. So for this one, all it does, and it's a new function now, so we have to change its name. Now it's g of x. G of x, f of x, those are function names. They're fancy y's. It's the same as me starting it off with y equals. We just, to declare that this is a function, we write it f of x, g of x equals negative 6x, and then negative 3 minus 6 is a negative 9. And so if I graph those two, so I'm going to graph those two lines so you can see how they move. So my original function, negative 6x minus 3, that's where we started. And I can open it up again, and I can do negative 6x minus 9. And there's my two functions that I graphed. So when it says move it down, okay, I took this function, and if I move it down, I don't know if I can grab it and drag it now. But if I move it down, it'll eventually line up with that one. But you could move it left as well. So here's the thing with these. Moving something left and moving something down technically do the same thing. They're technically the same movement. So here we're going to write g of x equals negative 6x minus 9. So this one here where it's saying shift up, you're just going to add 5 to the y-intercept. That's all you're going to do. Now when we shift it left and right, the math looks a little bit different. When we're shifting it left, we're messing with this x value now. Okay? So I've got f of x equals negative 5x plus 8. And I want to go left 9 units. Okay. Here's kind of where it gets weird, I guess is the only way to describe it. Going left, I mess with this x value. What I actually do is even though I'm going left, I'm going to add 9 to that x value. Okay. Then I have to simplify this function. I have to distribute and get rid of those parentheses. So negative 5 times x, negative 5x, negative 5 times a positive 9, so negative 45, and then plus that 8. Now I've got like terms. I can combine negative 45 and positive 8. So negative 45 plus 8 gives me negative 37. So that's my new function. So I'm going to name it g of x. So g of x equals negative 5x minus 37. That's shifting the line 9 units to the left. That's taking a line that looks like this and shifting it 9 places that way. It makes that big a change. So an up and down doesn't affect the equation very much. Shifting it left and right has a big effect. But it's backwards land. It's opposite land. So if you're going left, you add that number to the x. So if I'm going right, what do you think I'm going to do? Subtract it. So I would do negative 10, and I would do x minus 8, and then minus 5. So I'm going to leave that one in that form for you to simplify from there. The 2 pages that you picked up today, the last 2 on the ends, there's nothing to fill out on these. It's the last 2 we're going to put in our journal, but these linear transformation rules and different things, it shows you kind of what happens. So if you look right here in the shifts, so it's saying if you shifted it up 7 points, and I know you can't see it up here on the screen, but you can see it on yours. They're showing you that they added 7. They tacked a 7 onto the end. Here they're showing you if it's a horizontal shift, left 9 units, you can see where they put the x plus 9 in parentheses. This is a fantastic page to have the rules right at your fingertips when you have to do these things mathematically. Because you can look really quick and go, okay, oh, I just add it to the end. Just subtract it to the end. Oh, it's one of those where I stick it in the parentheses. So nothing to fill out on those. Those are just for you. The bottom 4 are really easy. All we're going to do is we're just going to manually move these. So 3 units up. So first I need at least 2 nice pretty points. So this is one nice pretty point. And then that is it. That one's a tough one. All right. If I go 3 units up, 1, 2, 3. That's all you have to do is count. Normally you want 2 nice pretty points. This one doesn't have it. So I'm just going to do my best to make these lines parallel. Maybe. We'll see. We'll see how good this turns out. But on the bottom, that's all you're doing is just manually moving. So 8 says 7 units to the right. So here's a nice pretty point. This is a nice pretty point where the arrow's pointing. This is a nice pretty point. Take that point and count 7 units to the right. 1, 2, 3, 4, 5, 6, 7. And do that with your other points. 1, 2, 3, 4, 5, 6, 7. All you technically need are 2 of them. 1, 2, 3, 4, 5, 6, 7. Move your points. And then draw your new line. Okay? So I'll let you do 9 and 10. So you've got 5 and 6 and then 9 and 10 at the bottom.